So here's one of those dreaded word problems. The first thing I do when approaching a word problem is I read through it to see that I understand the words, what it's asking for, and start thinking about what type of word problem it is, what information I already know, what I might need to know, and what type of problem it is, so I have an idea on how to solve it. A 13-foot ladder is placed so that it reaches a point on the wall that's 2 feet higher than twice the distance from the base of the wall to the base of the ladder. How far from the base of the wall is the base of the ladder? How high does the ladder reach? Now, the first thing I'm going to do with this problem is I'm going to draw a picture. So I've got a 13-foot ladder. It's leaning up against a wall, and I have to figure out how far up the wall it reaches and how far from the base of the wall, the base of the ladder it is. So I've got myself some level ground. I've got myself a building. It's straight, sorry. And I've got a ladder leaning up against the wall. Now, from the word problem, I know my ladder is 13 feet long. I do not know how far from the wall the base of the ladder is. I'm going to call this A. And I don't know how high up the ladder it reaches. I can call this B. A and B, because I already know I have a right triangle. And if I have a right triangle and I need to find the lengths of the sides or the length of the hypotenuse or something like that, odds are I'm going to be using something called the Pythagorean Theorem to solve it. The Pythagorean Theorem. In this class, we expect you already know the Pythagorean Theorem. If you don't, make sure you do know it, because I'm not going to be able to give it to you on tests and quizzes. The Pythagorean theorem says if I have a right triangle, then the square of the length of the hypotenuse is the sum of the squares of the length of the sides. That's a mouthful, but what that means is that a squared plus b squared equals c squared. And c squared is always the hypotenuse. It's always opposite the right triangle. So in this case, c squared is going to be 13 squared. A squared I have here as the base. It doesn't matter which one you label as A and which one you label as B, as long as it's one of those that is the shorter sides or the legs of the right triangle, the one that has the sides that are attached to the right angle. A squared is my base. A is my base, and a squared I can just leave as a squared. B, right here, it reaches a point on the wall that is 2 feet higher. Now in math, this means it's plus 2. So whatever I get, I'm going to add plus 2 to it. Plus 2 feet higher. Then twice the distance from the base of the wall to the base of the ladder. Twice A. So I have B, the height of up the wall, is going to be twice A plus 2 feet more. Twice A plus 2. 2 feet higher. 2 feet higher than twice A. I will put in translating English into math in the Canvas between the Prepare for Class 2.3 and the Homework 2.3. That should give you some help in translating this type of stuff into an equation, into numbers. So I'm going to put all of what I know from my picture here into my Pythagorean theorem. A squared is a squared. B squared is the quantity 2a plus 2, that's my b, squared, and c squared is 13 squared. My units are feet. I don't want to lose track of that because at the very end they're going to ask me the distance a is and the distance b is. So this is what I need to solve. In order to solve this, I need to set it equal to 0, right? It's a quadratic. It's a second degree polynomial. And to set it equal to 0, I need to expand this middle one out here. If you need to, if you have not done this often, rewrite it here. 2a plus 2 quantity squared is 2a plus 2 times 2a plus 2, and then expand it out. This is going to give me 4a squared plus 4a plus 4a plus 4, which is going to be 4a squared plus 8a plus 4. And that is added to a squared, and that equals 13 squared, which is 169. Now I can combine like terms and set it equal to 0. Combining like terms, I get 5a squared plus 8a plus 4, and this equals 169. I set it equal to 0 by subtracting 169 from both sides, and this will give me 5a squared plus 8a minus 165 equals 0. When I'm trying to solve this, and I, at this point in the course, only know how to solve by factoring. So I have to see if I can factor this. I know several different ways to factor, but the first thing I do when factoring is look to see if I can take out a greatest common factor. I cannot. So I can factor by guess and check. I can factor in the box. I can find a way that works for factoring for me. Okay, what I do usually is guess and check, and 5 has to be either a and 5a. That's the only way to get 5a squared because 5 is primed. Now I need to figure out what multiplies to 165, and one of those terms is going to multiply by 5, and the difference because this is negative, has to be 8. That sounds pretty daunting, actually, but it's not as bad as it sounds. If you do a lot of factoring, it won't be so bad. I'm going to take 165 and I'm going to factor it. And of course 1 and 165 doesn't really help me, but it helps me to have a list of all my common factors. 3 is 5 and 5. 15. And 5 goes into it 3 and 3, and 3 and 5, and 3 and 5, well actually, right here if I take 5 times 5 I get 25, and the difference between 25 and 33 is 8. So I'm going to take 5 times 5 and 33 times 1. I need a positive 8. So the larger product here has to be positive, and that's the 33. And this has to be minus. Always check to make sure you have it factored correctly. I have 5a squared plus 33a minus 25a minus 165. And this here in the middle is plus 8a. So I have it factored correctly. And now I use the zero factor theorem, which means I have a minus 5 equals 0 to make this true, or 5a plus 33 equals 0. So one of these factors has to equal 0. So I solve for both of them. Add 5 to both sides. A equals 5, or subtract 33. 5a equals negative 33. Divide both sides by 5. A equals negative 33 fifths. Now my distance is measured in feet. It is a distance. Distances have to be positive, so it cannot be negative. So A, the height, the distance from the base of the ladder to the base of the wall is 5 feet. So it's 5 feet along the base. And it is up the wall, it is 2 times 5 plus 2, or 12 feet high. So it reaches 12 feet up the wall, and it is placed 5 feet from the base of the wall. Then I go check and make sure that's what I was asked. How far from the base of the wall is the base of the ladder? That's 5 feet. And how high does the ladder reach? That's 12 feet. So I've answered both parts of the question. I hope this helps.